Hi everyone, and thanks for joining our webinar today. Today's webinar is Bego Varseo XS Exploring the Workflow. Our presenter today is Derik Brouillard from Bego. Thank you so much for being here today with us, Derik. If you have any questions during the webinar, please type them into the chat box and Derik will address them at the end. So now I'm going to turn it over to you, Derik.
All right, thank you, Katie. Thank you for having me. Excited to be able to present this solution out. Just a brief history about me. I've been with Bego now for approximately 7 years. All great years. Came on board initially to manage the production center. And that proved invaluable as it really got me introduced to 3D printing. We produced restorations using metal 3D printers, photopolymer, but we also did a lot of milling. So it allowed me to, gain comprehension on both technologies and really see where printing was advantageous to do. And now with this solution Bego has with the Varseo XS and the VarseoSmile crown, it's now possible to produce a ceramic hybrid crown in as little as 2 hours. And that's what we're here to show you guys and hopefully get everybody excited about. So we'll open up this presentation. So we're going to explore the workflow. Just a little bit about the agenda. We're going to give a brief overview of the 3D printing process. Okay, and that's just to kind of get everybody on the same understanding. We won't spend too much time here. I'm sure a number of you have experience printing or already know enough about it, but this is just to get everybody on the same level, so to speak. The next section, we'll go into our 3D printing system for crowns and bridges. We'll talk about the components of that system. So the resin, the printer, the curing light. Then we'll go into the workflow where we'll talk about how the material is processed to achieve, a beautiful crown to make patients happy. And then we'll go into the portfolio review and outlook, where we'll talk about where Bego wants to go with this resin. We don't want to tie it down to Varseo XS. We do have validations done on other printers. So we'll explore that when we close. To get everybody on the same page as far as 3D printing with resin, it's a manufacturing process where objects are created a layer at a time. It does that by using a CAM software or nesting software that takes an STL file and slices it up. And that data is sent to a printer where it will expose those areas that the CAM software outputs. There's two main types of technologies used in dental printing today. There's SLA printing and DLP. Both printing technologies will give you a high quality part, if you get the right system. The main difference between the systems is just the speed. So you can picture SLA as using a pencil and it's got to draw the entire area of the part, where DLP is more like a stamp. When the layer is exposed, the entire layer is exposed at once. There's 4 areas of dental printing, 4 major areas. There's the design, and that starts with an intraoral scan or an impression. That moves over to design software. And then you need settings, right? The crown needs to be designed with the proper settings in order to achieve a desirable fit. Once you have that crown design, that STL file, that gets moved into the nesting step. And in nesting, you need the printer settings, material profile, and STL files to really transform that digital file into something that the printer can understand to transform it into a finished object. In printing, you have the resin, the tray, and the job file, all combined to transform that digital information from the nesting step into those image slices, which are built a layer at a time, until finally the post-processing can start, where you'll need cleaning supplies, curing light, and finishing tools to transform it from its green state to a finished product. Some printer definitions. We'll talk about our printer. So just to make sure everybody understands what these terms mean as it relates to our printer. The resolution in XY, that's the minimum pixel or spot size. So you can think of that as the smallest feature the printer could produce. The resolution in Z, that defines the increments of the build process in the Z axis. And that's going to be dependent on your resin. So for our print system, it's all done at the same resolution, but other printers may state various resolutions in Z. The speed, that's how fast the print can build in the Z axis. The build platform, that's the surface that the object's built upon, and that's typically measured by size, and that gives you an idea of how many units you'll be able to print at once. The resin tray, that simply holds the resin used in the print process. And then finally, there's CAM software or nesting software. The terms are interchangeable there. And that's just a software used to arrange, support, and slice your STL files so that the printer can transform that information. Let's move on and talk about our 3D print system, the VarseoSmile Crown resin, VarseoSmile Temp resin, and the Varseo XS printer. Again, these are compact products. This is a small printer, but we consider it to be the right size for crown and bridges. The most revolutionary product is the first one up there on the left, and that's the Varseo Crown Plus. It's the first of its kind material on the market that's printable material, allowing you to print permanent single crowns, inlays, onlays, and veneers. Right now, it's currently offered in 7 of the classic Vita shades. We'll list those out in a couple slides here. And it's packaged in 250-gram bottles. And there's some advantages to that small package size. It's highly stable. It doesn't require frequent mixing. And it also leads to greater consistency in your shades. In the middle there is VarseoSmile Temp. So this is a broad range of indications that this temporary resin is approved for. It's temporary crowns, bridges, inlays, onlays, and veneers. It's available in 3 of the Vita shades in the same 250-gram packaging. And it's very stable. It doesn't require a lot of mixing. If you're using this daily, you probably won't have to mix it. It's stated as up to 30 days of stability. And then finally, on the right is the Varseo XS. This is our compact printer. It accommodates approximately 20 units. It's a very small footprint, takes up about the size of a standard cutting board, to give you some perspective. It uses DLP technology, so it's capable of building at 30 millimeters per hour. It's quite fast. And the resin tanks on this unit are easily exchanged. It reduces waste, but also facilitates changeovers, allowing you to cycle through either the 2 materials or the various shades. Let's look at some of the technical specs for the VarseoSmile Crown Plus. As I mentioned, the indication range is listed for permanent crowns, inlays, onlays, and veneers. It's offered in the 7 shades, A1, 2, and 3, B1, B3, C2, and D3. So it gives you a wide range of shades to select from. The flexural modulus and the flex strength, those 2 values really combine to make this a very stable restoration. While it's not as strong as traditional ceramic materials on the market, the flexural modulus allows this material to remain stable and resist breakage in the mouth, in the oral environment. It's a physically stabilized resin, so again, the material does not need to be mixed frequently. The package size at 250 grams. This helps reduce waste. Now, a 250-gram bottle will produce around 220 crowns. So by having a smaller bottle on hand, it reduces the risk of expiration, and it also helps minimize the complexities of lot and batch control. This is a listed 2A medical device, and it retails at $430.64. So very low material cost, considering the amount of crowns you can produce out of a bottle. The benefits of our VarseoSmile Crown Plus, it provides aesthetics through a balanced ratio of opacity and translucency. And this is made possible by a ceramic matrix in the material. It really helps provide a depth. It's got low thermal conductivity, so it's going to be very comfortable for patients. It's got excellent bond strength with luting and composites, so it's going to hold up in the oral environment. It's not going to debond and fail. It's very gentle to the natural antagonists and teeth. It can be easily polished, which leads to low plaque accumulation. So it's a very healthy material. Because this is the first material of its kind, we couldn't compare it to a similar product, but we compared it against conventional solutions. And what we found was this material in a printable format offers labs tremendous processing advantages, especially when you compare it to precious and non-precious alloys, which have investment in casting processes, which are prone to environmental variations. And it's much simpler than the metal ceramic and ceramic, full ceramic restorations in terms of turnaround time. There's no sintering, and there's no risk of failure during that sintering process. It's also got one of the lowest material costs across the board and is more aesthetic than current plastic and composite solutions out there, as well as more stable than the current solutions on the market. Again, to summarize those benefits compared to the conventional solutions, we see improved aesthetics over the alloys and composites available. It's very gentle on antagonist teeth, similar to alloys and composites. It's got the optimal resistance to discoloration, and in part that's that ceramic matrix that's in the material. It helps prevent the discoloration. And it's got durability similar to ceramics, but with a much faster production time. Moving on to the temporary material, we see that the indication range is a broad range, long-term temporary crown, bridge, inlays, onlays, and veneers, and that's up to 7 unit bridges. It's available in the 3 Vita shades, A2, A3, and C2. Just like the crown material, the flexural modulus and the flex strength combine to make this a very stable material, even up to that 7 unit span for up to a 12-month time frame in patient. It's a stabilized resin, so it doesn't require frequent mixing, and the shades will be very consistent. It's got that same convenient package size at 250 grams, and it is listed as a Class 2A medical device. With temporary material, there are other solutions on the market. So we did benchmark ourselves against some of the popular materials currently used. And like I mentioned, we have one of the broadest indication ranges, where some of these other materials can do some bridges, some may not do inlays, onlays, and veneers. So this is a material that does pretty much all your temporary needs. Its package size is convenient at 250 grams. It allows for a low upfront investment. And the water absorption and water solubility, those are real metrics of biocompatibility. So the water absorption is the metric used for discoloration, and the water solubility is, again, a biocompatibility matrix. And our material performs better than the current solutions on the market. The benefits of the VarseoSmile Temp, again, the wide range of indications makes it easy to select as far as the material is concerned. It's got improved resistance to discoloration over the current solutions. So for those temporaries that are going to be in for 12 months, this may be a more ideal solution. It's offered in convenient 250 gram bottles. It's stabilized, so the processing is going to be consistent. And it's easily polished, leading to low plaque accumulation and a nice healthy restoration. The printer, again, it's a compact printer, but it's right sized and tailored for dental industry. This printer has been optimized by Bego. Bego had a hand in changing some of the internals and as well as some of the mechanics in the machine to make sure it performs at the level required for dental. Some of the important improvements were the linear guide improvements, which this machine has dual linear guides, so the build platform is very stable when it moves, providing the accuracy needed for crown and bridge. It's got dust protection, which is important to keep the material, not contaminated or free from contamination. The new build platform included in this machine is proven to be biocompatible. That had to be changed out. It's of a stainless steel material. It utilizes adapted projection, which ensures high accuracy across the entire build platform. This is a validated solution out of the box. There's no calibration or user adjustments required. So it really is suited for the dental industry in that respect. It's got easy to change resin trays, so it allows for throughput in a lab setting. And it's got automated nesting features in the CAM Creator software that's included with the printer. As we already talked about, this is a DLP printer that prints at 30 millimeters per hour. It has a long life UV LED. The build platform allows for approximately 20 units. The resin tray holds about 90 grams of material, so one bottle will fill that resin tray up approximately 3 times. The resolution is 50 micron in X, Y, and Z, which is perfect for crown and bridge work. It's got a small footprint and weight, so it's conveniently shipped and moved around in a lab. And the nesting software. This is a lifetime software with updates included with no annual fees. And we'll talk about the updates when we get into the workflow. The updates are an important part of the system. The Varseo XS, it's got the accuracy needed for crown and bridge indications. It's got the speed to keep labs efficient and meet deadlines at 30 millimeters per hour. It's got a small material tank, which helps for the efficient changeovers. And it can be placed just about anywhere in a lab thanks to its compact size. The final component of the system is the curing light. So out of the printer, all objects are considered in a green state and they must be final cured. The auto flash is proven to transform the VarseoSmile resin from the green state to the final properties, a biocompatible material. And it does this with intense lights that help produce short curing times too. You'll see that the curing times in this light is approximately 6 minutes. You also have a benefit to add nitrogen gas, which will enhance the biocompatibility of the material. We're going to go into the workflow now and see how to actually, the steps involved to take it from the scan design step all the way through a finished restoration. So first, from a high level, we see all the steps laid out here, but the important part is that with the Varseo XS and the VarseoSmile crown system, is you can get a crown delivered in 2 hours. Of that 2 hours, it's important to note that about 40 minutes is hands-on. So the other time is when work is happening, post-cure, the curing time, the printing time, so forth. It all starts with a traditional workflow with an impression or a scan. And you need to send that to either your desktop scanner or just load the scan into your CAD design software. Output a crown file from your CAD design. You'll load it into CAM Creator. And CAM Creator is a very quick process. With each crown, you can nest a job with 3 clicks. So it can be ready to go to the printer in as little as 3 clicks. The printing time will take approximately 40 minutes, where then the objects are cleaned, trimmed, and smoothed. The curing time is approximately 6 minutes in the auto flash or the highlight, followed by, you check the fit if you do have model work, followed by polishing or individualization, and positioning and cementing. There's a key part of this, which is a validated workflow. Bego wanted to ensure that this is a solution that holds up to scrutiny. So Bego supports this validated workflow in a number of areas. In the design stage, Bego has established recommended settings which eliminate guesswork and again get you to a good fitting baseline crown out of the gate. You can always tweak those to create a little bit tighter or looser fit if you so desire, but we do have recommended settings that eliminate that guesswork. In the nesting area, we like to promote the use of the automatic support generation because that's going to lead to greater print consistency. Bego also manages the printer and material profiles, and that really controls the quality. And I mentioned the updates. The updates are delivered automatically. So the nesting software, the nesting PC, must have a connection to the internet, and that's so Bego can deliver these automatic updates, some of which could be critical to the processing. In the printing stage, Bego has developed this printer where no user adjustments are required. So the printer is set up out of the box, it's ready to go. And the RFID tags included on the material prevent unapproved resin types and eliminate errors, the wrong type of resin being used, the wrong shade of resin being used. So it really helps solidify the quality in the workflow. And in post-processing, Bego's done a great job of producing detailed instructions down to the level where they specify the tools and equipment required to achieve the material properties. And that's important when we're talking about these biocompatible solutions. Cam Creator, so just a brief overview and then we'll watch a quick video. It's really as easy as 1, 2, 3. Like most CAM software, you got to create a job. You got to load your parts and add supports, and then you simply send that to the printer. And as I bring up this video, we'll see those steps. Okay, so here we're just setting up the job where it's important to specify the machine and also the material, because the printer is going to do a check to make sure that the material matches what the job was nested for. We're going to load some objects. Here we're going to load a posterior and an anterior unit. And with just a couple of units, the CAM software does a good job with arranging them, but you can always have it finalize the arrangement as well. So just move them around a little bit. Next, you can click a button to generate the supports. So all those were automated. And if you happen to review them and you see some that you don't like, you can go in and remove them. And this is a good strategy to do. You may find some that end up maybe down in some anatomy that will make it a little tough to finish. So once you get the ones that will ease the finishing, facilitate the finishing removed, you're pretty much good to send this to the printer. You can just click the output button and it's going to ask you to save the file, and then it will start transferring to the printer. Okay, let me get my screen back up. Okay. So that was CAM Creator and how jobs are nested. So it is very, very simple to do. Like I said, 3 clicks and it can be sent to the printer. Some jobs that have been ran through CAM Creator, just to give you an example of what some of those jobs look like nested. And again, these were automatically nested. You can fit approximately 20 units, depending on your mix. You might fit more, you might fit a few less. And the jobs will print in approximately 40 to 45 minutes. If all the units are the same height, it doesn't matter if you have 1 unit or 20 units. It's all based on height with the DLP printer. So your print time is going to be relatively consistent in that 40 to 45 minute range. Similarly, with the Varseo crown material, so this is a crown job now. See how there's no bridges in this nested job? So that's fairly standard there. You'll be able to fit approximately 20 units and the same print time as the temp material, 40 to 45 minutes. That's not going to vary very much. When it comes to printing, there's 4 steps. First, you need to prepare the resin in the tray. And if it's the first time using the resin, you will have to mix it, before you pour it into the tray. It does need a mixing beforehand. Or if the tray has sat for a while, you'll need to mix it. As we saw previously, you got to create a job file. That's done in the nesting step with the CAM Creator. There's the printing step, which is virtually hands-off. You verify that the job starts, and then you can walk away for the 40 to 45 minutes. And then the post-processing. So once again, I'll pull up a short video so we can see these steps. Okay, so that was the resin tray being filled, and the bottle of material goes in the printer. and that's how it knows if the right material is loaded. If the right material is not loaded, you will receive an error when you transfer the job from the CAM creator to the printer. So the printer checks that data, and if it's good, it will receive it and start printing. And as you see, my colleague is checking the print job to make sure it's working, but otherwise it's hands off. Until the printer is done, where then you can remove the build platform, making sure to keep the resin covered and protected. That's a key point here, is you want to keep it free from sources of contamination whenever it's exposed. Okay. The post-processing, there's 4 steps. There's the removal and cleaning. So that's removing the printed object from the build platform and the cleaning. Cleaning is done in 2 baths of either isopropyl or ethanol alcohol. You can use either or, but it should be done in 2 baths. The first bath that you'll see in the video is 3 minutes, and the second bath is for 2 minutes. The first bath is what we would call the dirty bath. This is one that can be used, several times over with the VarseoSmile material. The second bath is a clean bath, so it's your fresh alcohol or ethanol, and that should be replaced more frequently, at least daily or perhaps more frequently depending on your volume. We'll see the finishing, the removing the supports and sandblasting. So removing supports is done with a double-sided diamond in either diamond burrs or carbides. And sandblasting is required, and that's done with a 50 micron glass bead. That's just to remove a chalky film that's left over on the material that you'll see in the video. That's followed by a fit check and cure in the auto flash. And again, that's approximately 6 minutes total time. And then polishing or individualization at the end. And you can individualize, you can carve more anatomy, either using your superfine diamonds or carbides. You can add stain and glaze. A GC OptiGlaze kit is the recommended kit to use, but any compatible composite stain and glaze kit should work on the material. Or you can use traditional polishing media, such as pumice and a bench lathe, or composite polishing blocks of various grits. So let's check out a video. So the object is removed. The build platform is wiped back down and reinstalled in the machine, and it's keyed. It can only go in one way. The object is placed into a wash basket and put into the first bath. Here they use ethanol. And you'll want to make sure it's set for 3 minutes, and that's unheated. Next, it transfers to a clean bath of ethanol for 2 minutes, again unheated. It's then rinsed using some fresh ethanol, blown dry and inspected, and you should see that chalkiness, uniform chalkiness on the outside. You'll remove the supports before sandblasting. That allows you to reach all the areas very easily. So you can cut the supports with the diamond disc and then finish them with diamond burrs or carbides, fine or superfine. Here you can also carve anatomy in if you would so choose. It is easier in the green state. Here it's being sandblasted before curing. That removes that chalkiness. And it's going to be cured in 2 cycles. 1500 flashes, which is approximately 3 minutes, and then flipped over, followed by another 1500 flashes. Here you see that they're going to carve some anatomy in there using the diamond burr. And then they're going to finish this unit simply by polishing using conventional blocks. That I believe is a medium grit. And you'll definitely want to work up to a fine grit and get it to that high shine to prevent that plaque and really bring it to its final state. Or like I shared, you can use a stain and glaze kit on it and give it some individualization in that manner. But in the end, it fits the model nicely. Okay, let's go back to the presentation. So as we step through the workflow, there are some critical points just to make note of. As far as cleaning, you want to make sure you're using separate cleaning baths for the temporary and permanent resins. And that's really because they're indicated for two different purposes, the temporary resin being up to 12 months in the mouth and the permanent resin being a long-term restoration. So you really don't want to use the same bath for both materials. Another point on cleaning is to observe the time listed in the instructions for use as far as how long to keep it in the alcohol. Too much time in the alcohol or ethanol baths can have adverse effects on the material or the shade. It's recommended to use a dedicated build platform for each material, not each shade, but each material. So one build platform for your temp material and one build platform for your crown material, your permanent material. And again, that's just to prevent the carryover from one resin to the other. Curing is a critical part of the process. So it's really important to refer to the instructions for use and use only those lights which have been approved. Using lights outside of what's been listed in the IFU may not be bringing the product to the final properties, which are important for the patient. Like all photopolymers, it's important to store the resin properly, protect it from sources of contamination. And the resin trays should be used for a specific resin and shade. You really don't want to try cleaning these out and switching materials. There are, some seams which are very tough to clean material out of. And these resin trays are cheap enough, or should be cheap enough where, it's worthwhile just to have an extra one on hand. They retail for approximately $200 and they're listed for approximately 100 prints. So after 100 prints, you should consider replacing them. You may get more. Use your quality as that determination. If things are still fitting well, then there's no need to change the resin tray out. Well, Bego did put together a bundle, right? So we offer the printer along with the curing light and resins. There are some items that are not packaged to be fully turnkey out of the box. And those are some of the accessory items like nitrogen gas. If you intend on using that for your curing, that is something that you'll have to have on hand. The curing light does come with a hose to hook up to a bottle, but you would need the bottle and also a regulator. The isopropyl alcohol or ethanol, that is also an item you would have to source, along with an ultrasonic with containers, a spray bottle, and perhaps a small brush. The small brush will help clean out some deep anatomy on posterior units from time to time. You may find it helpful. As we talked about, the sandblaster with 50 micron glass media is suggested by the workflow. I'm sure a handpiece is already found in every dental lab. Just make sure you have some diamond discs, carbides, and diamond burrs. And I would suggest keeping a kit put aside for these materials. You'll want to make sure you have polishing media and tools, and just those materials which are compatible with composite materials are fine to use on this product. You can also consider adding a stain and glaze kit. The GC OptiGlaze kit is a very good kit. It comes with a couple chroma adjustments, so you can actually bring the value up and down, a little bit here or there. So if you're in between shades, it could help you get to where you need to be. And the last two items, the playing cards and paint strainers. Those are related to really resin maintenance. If perhaps you let your resin tray run out of material during a job, you may have some material that's cured and stuck to your resin tray. You can still use that resin tray, you just have to remove the cured material. And the playing cards do a great job of that without damaging the protective film that's on the bottom of that resin tray. So having a deck of playing cards around is a good idea. And those paint strainers, those can be found at hardware stores. That's, again, if you have a misprint like that, it's recommended to just strain the material just to make sure there's no particulate left in it. Any particulate could subsequently damage that protective film in the next job. Finally, we'll talk about the portfolio. We'll review this Varseo compact product portfolio and talk about where we're going in the printer validations. So again, the Varseo compact products, it's the right size for those crown and bridge indications. We have our 7 shades of resin listed there on the left for the Crown Plus resin, the first of its kind for a permanent crown. Again, the 250 gram bottles makes it a very affordable solution to buy into. You know, you can pick and choose your shades. No one has to offer them all. You can base those shades on your market. Then there's the VarseoSmile Temp. Again, competing against some other products out there, but this one offers you the broadest indication range and has some of the best biocompatibility markers on the market. So for those temporaries that are going to be impatient for those full 12 months, this might be a good solution to consider. And then the Varseo XS, the compact printer with the accuracy needed for these crown and bridge indications, along with the resin tank and build platform. So those are the consumable items for the printer. So the outlook, right now the VarseoSmile resin, we're validated with some other printer companies. The full line of Bego printers. So our legacy Varseo printers, if you happen to have one of those kicking around and you want to inquire about getting this material set up, the VarseoSmile material, it is approved to use on that material, and we can help get you going. The VarseoSmile resin's also been approved to use on the Formlabs printer, the Asiga Max, and the SprintRay Pro 95. We want to continue to really share this print material with other print manufacturers. We want to be able to get this on as many printers as possible, those printers which are proven to deliver the accuracy needed for crown and bridge work. Not everybody needs to buy a new printer. Some people have already invested a fair amount of money into their printer and are happy with their printer and their solution. So if it has the accuracy needed and it's a popular printer, we hope to get it validated on your printer. We want to continue to introduce new and improved materials. You know, one material which is now compatible with this Varseo XS printer is our CAD-CAST material. It's been revamped and reformulated. So it's now compatible with Varseo XS. So not only can Varseo XS do your permanent and temporary crowns and bridges, it can also do RPD frames that you can, you know, invest, burn out, and cast. We want to continue to develop those validated workflows. Bego believes that this is a key part of the distinction to our brand and the solution is that it's a validated workflow. Bego's done a great job at ensuring that the pieces we suggest, the pieces of equipment and the tools and processes defined lead to a biocompatible product. It's not, we don't want people to have to buy a printer from one company, curing light from another company, and resin from a third company, and hope that it provides them with a biocompatible product. We have evidence to show that this is a biocompatible product, and that's why we want to continue working with our partners such as Formlabs, Asiga, SprintRay, and others to continue to enhance our exposure with this material. With that, we've reached the end of our presentation. So we wrapped up a little early, but perfect time. We can get in a lot of Q&A if they're out there.
Hey, Derik, right now I don't see any questions, so anyone who has any questions, don't be shy. Go ahead and type them in and Derik will be able to address them.
While we're waiting for some to come in, I'll cover some that might be interesting to some folks. One thing I didn't include in this presentation were thickness requirements. So for the temporary material, if you're not doing bridge indications, it's easy. It's 1 millimeter, whether it's interior or posterior, 1 millimeter thickness requirement. And then if you're doing a bridge, it's 1 millimeter in the anterior region and then 1.5 millimeter in the posterior region. And then your bridge connectors in the anterior, you'll want 12 millimeter connectors, and in the posterior region, 16 millimeter connectors. The crown material, the permanent solution, that has a requirement of 1 millimeter thickness. Other questions that have been coming up kind of frequently are cementation, some practitioner questions, getting ready for doctors asking what they can use. So for the temporary material, you can use traditional temporary cements such as Temp Bond NE. And for the permanent, you have some options. You can use self-adhesives such as Rely X, or you can use composite cement with primer. And VarioLink Aesthetic DC and Monobond Plus is cited as being a good solution for that.
Awesome. So we did have one question regarding layer height that you recommend. So I think you just reviewed that, right?
No, so if I think I see it. Is this the Asiga question that came in?
No, it's the first one that says, what layer height do you recommend printing at?
Okay, so with the Varseo printer, the XS printer, it's going to print at 50 micron, and that's fixed. With our system, we consider it a validated system, so things are closed. There's no editing them. It prints at 50 micron thickness. It also prints at 50 micron thickness on the Asiga, on the Sprint Ray, and on the Formlabs right now. So I think that's going to be a trend where that's the resolution this material needs to print at.
Okay, perfect. And then there's a question that came in about cost. You guys can reach out to your Zahn representative and they'll be able to help you with that. I think you just compared it a bit with Asiga, so that covered that question.
Yeah, the only difference with our product and Asiga, be transparent. Our product has our printer, right? We have the 3 materials available for it right now: the Temp, the Crown, and the CAD-CAST material. It's a great printer for those materials. If you're looking to do, your models and night guards and a broader range, then that's where the Asiga makes sense. But if you're looking for quick, this printer is the quickest of the bunch. At 30 millimeters per hour, this really has more speed to get to those crown indications, especially when you're printing by shade. So.